Okay, so let's talk about this slot we're going to cut in the end of these parts a little bit. Okay, we're going to cut a slot that's 250 thousandths wide plus 5 thousandths minus nothing. And that slot is going to be located 3/16 of an inch from one edge. Okay, I'm looking at this now. I probably could have made that 0.188 dimension. I could have made that 2-place easily because location of the slot's not critical at all. So let's call this 0.19. We don't care about the location, so probably really the way the math works out is the slot is centered on this part. So that's what I'm going to do. I'm going to center the cutter up on the part, and I'm going to mill this 250 thousandths wide slot. 563 deep. This probably could be 560 deep as well, 2-place. It's not, the depth isn't critical. It's just clearance for those knurls that fit in it. Okay, that's a deep slot for the width. To get a 250 thousandths slot, you can't use a 1/4 inch end mill because the end mill is going to mill a little bit oversized and maybe too much oversized. So you'd want to use a smaller end mill, like a 3/16 end mill, for instance. My 3/16 end mills I have on hand, I have this standard 2 flute here. These only cut a 1/2 inch deep, so that won't reach the bottom, so I can't use that. I have a long 3/16 end mill, this 4 flute guy here. That'll reach, but that's really kind of overkill. I don't need an end mill this long to mill a 9/16 slot. This thing mills about 1.25 inches deep, so I'm not going to use that. What I do have is this little carbide end mill here. Okay, it'll mill a slot 3/4 of an inch deep. It's 3/16 in diameter. That's perfect for this application, so I'm going to use this guy. Okay. So first thing we need to do is center up on the part here. Let's get these other end mills out of the way. So I'm going to pick up one edge. I'm a little torn here. I have a digital readout, so I like to use that. That's what I use normally, but I know a lot of you guys don't. So let's do it without the digital readout. Let's loosen up the dial on my Y-axis screw, and the diameter of this edge finder is 200 thousandths. Okay, if I want to move the spindle center line up even with the edge of the part, I need to move in half of that. So half of 200 is 100. I'll set my dial 100 thousandths before 0. So now when I move the Y-axis to 0, like that, the center line of my spindle is lined up with the back edge of this part. Okay? So now I can move in half of the width of the part, 625, and be on the center line of that slot. So half of 625 is 312 and a half, 5/16 it is, 312 and a half. 312 and a half thousandths right there. Now I'm going to recenter my dial to 0. So just loosen it up, set it on 0, be careful you don't move anything. So now the axis of my mill is lined up on the center of that slot. It'll be easy to cut the slot on location. Let's take this drill chuck out. Put this 3/16 carbide end mill back in. I know it might be tempting to throw this end mill in that drill chuck and mill with it, but don't do it. I've had that question asked before. What happens is the chucks don't hold the end mills tight enough, and they can creep out on you when you mill with them. And you don't need that kind of surprise. They'll come out, you'll end up milling a slot deeper than you want, or it'll come all the way out and cause all kinds of problems. So don't use drill chucks for end mills. Use collets. Alright, let's see where we're at here. zoom in a little bit so you can see what's going on. Alright, so I have my end mill right on center. Let's bring the table up till it just touches the part. A lot of people wonder how you pick up a part like that. You can either do it by eye or you can just slip a piece of paper between it. Bring your table up till the cutter grabs the paper. Okay, then you know you're about 3/1000ths off the top of the part, so then you can kind of sneak up on it till it scratches. Right there. I'm going to set my dial on 0. Now, if I move up the depth of the slot, 563, 563, I'm going to set my dial on 0 on the table, so I know where my finished dimension is, or where I need to finish up. Now I'm going to drop it down about 10/1000ths just to leave enough for a cleanup cut. Alright, let's talk about RPM on this cutter. This is a 3/16 cutter, and it's carbide. Carbide can run about 4 times as fast as high-speed steel. So instead of 100 surface feet per minute, we can use 400. So 4 times the cutting speed is 4 times 400 is 1600 divided by 3/16 of an inch. 1600.188 divide gives us about 8,500 RPM for this little baby. Obviously the mill won't go that fast, but we'll crank it up to a couple thousand. Let's start cutting. It's a common mistake to run a cutter too slow. That's how you break cutters. Crank this baby up all the way. It's 4,000 RPM. So now we're going to plunge cut. Let me start down this other end here. I'm going to plunge cut down to my stop. It's a lot easier on an end mill than side milling with it. I always plunge cut for roughing slots out like this. It actually takes less time and it's a lot easier on your end mill. Kind of play around with how big of steps to take here. I'm taking probably 30, 40,000 for each step. Go too much and the end mill won't like it. You just kind of step your way along. Going 50, 60,000 per step. Seems to be feeding okay. Go too far, it just takes too long to cut down. There's too much load on the end mill. It just takes longer. It's not going to hurt the end mill unless you try to force it. So we got that slot roughed out now. Now we can side mill back through it to take all the steps off. Now we have a roughly a 3/1000 wide or 3/16 inch wide slot almost to depth. So now we got to go. Now the difference between 3/16 and a 1/4 inch is a 16th. We've got to take half of that or a 32nd off each edge of each side of this slot to take it down to size. So let's do. Let's go 30/1000 each direction. Okay. I'm going to climb mill on this. It's such a small cutter, it doesn't really matter. It's not going to grab. Maybe if you have a light milling machine, you might not be able to do this. You kind of have to know your own machine. And now we'll go 30/1000 in the other direction. If you're using a dial, you got to allow for backlash. You got to go farther than 30, then come back to it. And there I took the backlash out. Alright, so now I'm going to take another cut in the same settings just to make sure that you get all the flex out of the end mill. Matter of fact, I'll take a couple cuts to make sure you get all the spring out of the end mill. Okay, do the back one, we'll go back past the 30, then come back to it, so take all the backlash out of the lead screw. Right there. See, it's still taking a little bit off. Let's spring back on the end mill. The end mill's flexing, so you want to take a couple free cuts to get rid of that flex. So see, now it's hardly touching. Alright, that slot should be pretty darn close to 1/4 inch. A little less than 1/4 inch. Now to check that, I'm going to use gauges. I'm going to use gauge pins. Okay, I have these. These are really inexpensive tools to have around the shop, and they're really handy. They're just a box of pins, precisely ground to different diameters. Okay, this set runs from 61 thousandths up to 250 thousandths in 1/1000th inch increments. Okay, there's just little ground pins. They're really handy for use around the shop. So in this case, I'm milling a slot that's 250 thousandths plus 5 minus nothing. So my slot needs to be between 250 and 255 thousandths in diameter. So I'm going to select the 250 thousandths pin. Okay, this pin needs to go into the slot, and I'll select a 255 thousandths pin. Where are we at here? Okay, this one should not go in the slot. This is a go, no-go gauge, basically, right? Okay, the 250 should go in, the 255 should not. So let's go and check out this slot and finish it up to size. So let's see where we're at here. The 250 should not go in. It does not. Either one of them goes in. That's a good thing. So let me see here. Let's just take a quick check with the calipers and just see how far we're off. Okay, this is telling me about 243 thousandths, so we have at least 7 to go. So I'm going to take 4 thousandths per side off. That should get us really close. So about 34 thousandths each direction. Take a couple free cuts. And 34 in the other direction. Okay, so now our 250 thousandths pin might just go in there. It does, okay? The 255 should not. It doesn't. So that puts us right in our tolerance we were shooting for. Okay, so that slot's done. Not going to spend any more time on it, right? As long as it's in between our +5, -nothing tolerance, we're good to go. I don't care where it is. I don't care about the specific size. So I'm not going to waste any more time on it. Let's move on to, let's cut those 45-degree chamfers next. Okay, we got two 45-degree chamfers to put on this thing. One of them is 0.13 by 45 and the other is, did I forget to put it on here? Yeah, I did. The other one's 3/16 by 0.45, I think. Let me check it. I'll have to update the print. Yeah, 3/16. So I'll have to add that to the print. But the way I'm going to do that is I'm going to do these chamfers, I'm going to use a V-block. Okay, I'm going to set a V-block in my vise like that. And I'm going to set the part in the V. Okay, and that locates the part vertically, so once you get set up, get your chamfer set up, you can just throw all the parts in and do them all at once in one setup. So I am going to be working on the left side of the vise just because there's nothing in the middle to set the V-block on, and I don't want to add a parallel because there's not a lot to grab on already. So I'm going to work down here in the one end of the vise. Like that, okay? But when I do that, if I'm clamping on a part down on the left side here, that means the right side's gonna, or the movable jaw is gonna cock a little bit. So to keep it from doing that, just use yourself a little machinist jack. And just put that in the other end here. To keep it from doing that. Alright, so there we go. I'm going to use a 1/2-inch end mill. You have to be a little bit careful when you're doing stuff like this. Slow this down to about 800. We already figured that out. 1/2-inch end mill. Okay, there's two ways you can do this. You can end mill it on the top here like this, but if you do that, there's a big risk that if the part moves, it can grab. It's not a good thing. So what I like to do, preferably do, is side mill down here like this, okay? In this case, if the part moves, it's going to move away from the cutter. It's not going to bite into it. These are just 2-place decimals, so all they are is just ruler measurements. You can put a mark on your part, or you can just eyeball it till you get close and then check it. This needs to be an 1/8 inch, so somewhere in there. Let's take a look at it. We are at about 100 thousandths. We'll go a little bit farther and we'll call it good. I do have the V-block against the stop here. I don't know if you noticed that. So that way all my parts can be the same, will be the same. Let's check it out here. See how close we are. Again, this is a low accuracy dimension, so as long as you get close with the scale, it's fine. Well, that's about an 1/8 inch chamfer. So let's go ahead and put that on all the parts now. Now we're set up. It's just a matter of swapping parts out. Make sure that parts sets square in the V-block and the V-block's pushed against the stop. Then you can just go ahead and set your dial on 0 for where you want to end up, and then just go ahead and conventional mill will rough it out like this. Move in the last 10 thousandths or so and take a finish cut climbing. Okay. Is it focusing? There it is. So that's all there is to that. Let me do the other one. Okay, so we'll do the other part. Rough cut within 10. And a finish cut. Okay. So now let's do the 3/16 chamfer on the other end. Make sure it's oriented properly. Check your drawing. Make sure you don't get it 90 degrees out. Whoops. Okay, it's oriented the same as that first chamfer we did, so just like that. Okay, for this one I put some layout lines on here, 3/16 of an inch up from the edges of the part, just to make it a little easier to see. You see the layout line right there? Maybe, maybe not. Believe it or not, there is a line there. So that's, you can use that to tell how far to go to get this 3/16 dimension. Or you can use Treg, if you want to work it out with Treg. Figure out how much farther you have to move over. It's probably easier just to put a line. Just mill it till the line goes away. Right about there. There we go. Again, these chamfers are two-place dimensions, so they're not very critical, so just measure them with a ruler. Don't waste a lot of time. Alright, so this is done. 3/16 chamfer there, 1/8 chamfer there. We're getting close. All that's left to do is, well, we still got to do one more part. All that's left to do is ream the holes for the dowel pin. Alright, now we'll just put the drill chuck back in and set up to ream the dowel holes. Okay, this dowel hole we have here is I have two separate diameters. I have 250 plus 1 minus nothing going down to the slot, and then the second half of it I have 250 plus nothing minus 1. So what that amounts to is I have a slip fit on the first half and a press fit on the second half. That slip fit, that initial slip fit, makes it a lot easier to put pins in and out. Okay, and this pin's going to go in and out because you're going to probably want to change the knurls will wear out, so you'll have to change them out every once in a while. So I do this just to make it easier to press the pin in. If it's an interference fit all the way through, it's hard to get the pin started straight. By making it a slip fit, the first half takes care of that problem. So we have a hole to put in here, 1/4 inch from the end and 3/16 up from the side. That's centered side to side, and 1/4 inch from the end. So let's set up on that. I'm going to use my my stop for these. Okay, so just run the part into the stop. I'm going to use the other part in place of the machinist jack so the jaws don't turn on me. Like that. And throw the edge finder in and find our location. I'm going to go back to using my digital readout now just because I can. Let me zoom in here so you can see what's going on a little better. Okay, it was running. So the edge finder kicks out. Do the same thing on the other side. And find the middle. Okay, you can do the same thing with dials, just have to do the math. Digital readout does it for you. So that's zeroed out in center. And we'll pick up the end. Touch, move in half the diameter of the edge finder. Plus 1/4 inch. There. Okay, so now we're using a 1/4 inch reamer. So we have to drill a hole slightly undersized. I'm going to use a 15/64 drill. For reamers, I like to use a 32nd undersize, or 64th undersize for reamers up to a 1/4 inch, and then a 32nd undersize for 1/4 inch to 1/2 inch. Anything bigger than that, if you run across that, just add a little more, a little more meat to it, a little more material. So this is a 15/64 drill. This can go all the way through. Grab a couple reamers. Okay, I have a 249 thousandths reamer and I have a 250 thousandths reamer, 1/4 inch reamer. Okay, I know from experience that 1/4 inch reamer is going to just ream just slightly oversized, so it'll give me a nice slip fit. through my pin in the first half of the hole. Okay, this is a 249. This is going to go all the way through. Slow it down a little more. Reamer is to run about half the speed of the drill. And always use a little bit of oil with your reamers. Okay, so that's a 249 through. Make sure the chips are out of the way there. And I'll throw my 250 in. Oh, you guys can't see any of that, can you? Alright, this is better. You missed the first part, but you know, it's the same as the second part. Okay, this is a 250 thousandths reamer. I only go through the first half of the hole. Okay? Like that. Like I said, I knew I'd screw up at some point. I'm not going to reshoot that, because I think you guys know what was going on. Just take the burrs off for chamfer these holes a little bit. Just take the burrs off. And these parts are done, except for the case hardening. So I guess we ought to do that next. Okay, I mentioned this part needs to be case hardened. I think what I'm going to do is wait on that until all the parts are done, because there are a couple steel parts in this project that have to be case hardened. So it's a lot easier to do them all at once. I was noticing when I tried the knurl in this slot, the wheel, it was a little tight at the bottom of the slot, so when you check the slot width with your gauge, make sure the 1/4 inch gauge goes all the way to the bottom. Okay. I put it back in the mill and took another cut on it just to make sure that the knurl goes in. So it's 1/4 inch wide all the way to the bottom. And it does. And the pin goes in the slip side of the hole, and well, it went through the knurl. Probably work better when I get all the burrs off of it, but that's the tight one. There we go. There we go. Pin goes all the way through the knurl wheel to the hole, the press fit hole. So that's good. I'm going to make the change on the drawing. I'm going to add the dimension for that 3/16 chamfer. And like I say, make sure when you cut the 1/4 inch wide slot, you check the width at the bottom of the slot to make sure that it's at least 1/4 inch, at least 250. So that's pretty much it. I think if I have time, sometime this weekend, I'll start on another part. But I'll see you then.